Hello and welcome to the third video on the N64 for creating 3D graphics. In this video I'll be showing you how I work with OBJ models and convert them to a usable format within LibDragon. So let's get started. So first off I'll go through the OBJ format itself. Then I'll be using Blender to create the 3D models. I'll show you how to create a 3D model and how to quickly add a texture to it and then export it. And then I'll go through the LibNDS display list format, which is the format we will be converting our OBJ model into, as it's more compact than arrays of floats. I'll then create a 3D scene and show you the code for that, and then we will add an extra model into that. So let's quickly go into the OBJ format. So I'm just skipping over all this other stuff here as per the previous videos, which you will need to watch to make sense of this one. Obviously everything's made of polygons. That's the position in 3D space. Those are the rotations, and we'll be designing our models in local space size, and then once we put them into our scene or our world, we scale them to world space. So let's go over the OBJ file format quickly. So here we have a textured cube, so that you can visualize that. I'll open Blender a moment. So I'm using Blender 3.1. I'll quickly delete everything a moment, and then I will add a cube. So here we go, here's a cube, and now I will apply a texture to it. Just so you understand what we're doing here. Okay, so let's start with this one. So when you first off add a texture, it kind of applies it over the whole model. This isn't what we want most of the time. So first off we need to go into edit mode, and then another thing I would advise as well is select faces here, and then select face here, and then triangulate faces, as we'll be working with polygons or triangles. So you'll see here there's 2 triangles per face of the cube. So what we want is we want that one texture to be sized on every face. So go into UV editing, and then you should have a left and right window here. So this is, scroll across here using the middle mouse button. I'll put that to textured here, and then we zoom in. Now if you've got a full-size keyboard, then pressing the number keys will change the perspective here. So see, pressing 1 puts you in the front perspective there, pressing 3 right side, 7 is the top, and then if you hold down shift and press 1 you'll get the back side. If you hold down shift and press 3 you'll get the right side, and if you hold down Shift and press 7 you'll get the bottom. So we'll go back to the front here. So click off of this and then select that one face there, and then on the viewport on the left here, this is the UV editing window here. So you see here, these are the vertex, so the dots that make up the face. So what we want is we want these to be resized and repositioned on the image here. So one thing I recommend is constrained to the image bounds. So if you move that with G to move, you'll see that the vertex stay within the image. And then once you've finished doing things, I would constrain it to the center. So what that means is that each of the vertex will snap to a pixel on the image. Now if we move it, it moves. So that's the top left there. So another thing to note as well is that this is probably not it's not rotated correctly how we'd want it. So a quick way to unwrap this face only is to right click on your mouse, go down to unwrap faces, and then project from view bounds. What that will do is it will match what we see through the front perspective here, and then scale that view up to here. So now what we've got is we've got this here matching here. So now if we rotate our cube around, you'll see the front face is fine, but all the other faces are now off. So we would now wish to do the same for all the others. But what I would do first is move these inside the image. These aren't aligned. One way to align them if they're out like this is to press S and then 0. Okay, not like that. S and then X for the X-axis only, and then 0. And then what that's done is that scaled both of these on the X-axis to 0, making sure that they're aligned. And then one thing you can do as well to move these is press G to move, and then X, so that it only moves on the X-axis. So on the vertex window here, there's only X and Y to move things around on. So you see you could use the various icons here. What I tend to do is use the shortcut keys to quickly navigate around here. So if we press 1, we'll see that we've got the front view there. If we press 7, we've got the top view. So let's select both of those triangles there and then unwrap the bounds. Select both of those, press S to scale, and then just move it back slightly so that they are in there. And then you would do that for all of the other faces here. So this one here would be, that would be the back there. So if I press Shift and 1, sorry, it's Control and 1. So Control and 1, Control and 3 does the so 3 gives you the right side. If you press 3 on the numpad, if you hold down Control and press 3, that will give you the left side. So that's a quick way to rotate the object by 90 degrees there. So if we hold down Control and 1, get back to the back face here, and then unwrap those to bound, and then scale those back. And then we would do that for all of the faces on the cube here. And then what you would do, once you've got everything that you wanted here, if you go back into object mode there, and if you press N, then it will bring up this window here, and you want to make sure that when you export, all the rotations are zeroed, the locations are zeroed, and the scales are 1 on all directions there. Notice here that the dimensions, these are the actual dimensions of this. Obviously I don't want to, so I'll put that back to 1. And then what you'll notice is the scale is now 0.5 here. So to correct all of these here, Shift and A, sorry, Control and A, and then apply scale. What this will do is put the scale back to what this is here. These will be like the default sizes. So when you export everything, you need to make sure that, so for example, if I rotated this, rotate X 45 there, we don't want to export this with any rotation values on here, so we would Control and A and then rotation. Now this would be the default rotation when it's exported, so you know that there is when you rotate it, once you've loaded it in, this is the default at 0, 0, 0 on all rotations. So to export this, go on to File, Export, and then you would select Wavefront Object. So one thing you might note, once you've installed Blender, is you might need to go into Preferences and then Add-ons, and then you would select working with OBJ files, possibly other formats you might come across as well, like FBX. I think there we go, import and export wavefront objects. You want to make sure you've got that. And then let me think, I think Collada is another format in here I recommend selecting as well. So notice some of these are tools I use here. Where are we? There should be one for DAE. I can't remember whether that's a default one or not. And then export that as a wavefront object. I usually go into my pictures folder, and I've created like a models folder in here, and then just select wherever you want to save it. Make sure it's selection only, and then make sure Y is up and minus Z is forward, and then triangulate faces and keep vertex order, and then you would export that, and then you would have an OBJ file which looks something like this here. So the OBJ file format is split into a number of different pieces here. This is the most basic one. The only bits that we are really interested in here are the vertex, which is with a V here. See, this is the reason we just limit things to 1 when we scale everything. Otherwise you'll end up with huge numbers here. And one thing to note is the LibNDS file format, you can't have any sizes greater than 7 because of the restraints in the number ranges that data type supports. So anything with a V is a vertex. Anything with a VT is a vertex texture coordinate. And you notice that there's only 2 of these, and that's because we have a U and a V texture coordinate there, so there's only 2 positions. Sometimes people call it S and T as well. And then we have the vertex normals used. So basically what happens is the format selects unique vertex. Same with the texture coordinates as well. These are all unique, and then when it sort of reconstructs it, which it does here, so this is a face here, and then what if you've exported it with texture coordinates like we have here, then each face has 3 parts to it, or 3 groups if you like. So the first one points to the vertex position, the second one points to the texture coordinate, and then the third one points to the normal to use. And these numbers here, they go from 1, not 0. So 1 is always the first one in each of these groups. And then you'll see we need 3 vertex to form a face. So each face here is basically a triangle. So to construct this cube here, we have to go through the list here and basically pick a vertex position, texture coordinate, and a normal for each vertex of the face, and then you kind of end up with a huge array of floats at the end of it, which you would then use to construct your model. However, this text file coordinate here can get very large, which is why the tool I use converts them into a different file format. So if I open one of these up a minute, so this is my OBJ tool here. So I have 2 versions of this tool. I have a Windows version and a Linux version. The Windows version is pre-built and supplied with the source code, whereas the Linux version is built for Linux Mint 64-bit and is provided with the source code. So if you've not got Linux Mint 64-bit, you might need to recompile everything from a source. You'll also need the SDL2 library for that as well. So if you open that up, this is what the OBJ tool exports. It basically converts everything into, we've got signed shorts at the top here in hexadecimal format, and then the indices at the bottom here using unsigned shorts. So this here looks better than this here, and this is obviously easier to work with here. Basically all these numbers, each one of these numbers represents the vertex position, texture coordinate, and the normals there. So the format you just saw there, the NDS format, is a fixed point number format. So what fixed point is the way that floating point numbers were represented before the floating point standard. On the early machines, which didn't have floating point processors in them, or maths coprocessors that had a floating point unit processor, floating point numbers used what's called fixed point. And the way that works is you have a standard data type. So if I just open a random text file here, So we'll use a byte as an example here. So we have 8 bits in a byte. So if we split the top nibble and the bottom nibble there, we would have 4 bits at the top and 4 bits at the bottom. So this would give us 15 here at the top, and then we have 15 bits which could be used as fractional numbers. So the first fraction there is actually 0.5. The second one would be 0.25, and then the third one would be 125, and then basically these are halved, or basically these are halves going down that range there. So you would have like the decimal point there, if you like, and then you know that these are the whole number parts, and then these are the fraction parts. So to convert a number, say you had a number 5 there, or say 5.5. So the whole parts would be 5, and then you would shift that 4 to the right. And then that would be shifted as well. So you would shift that 4, and then that would actually be the fraction parts would be like shifted 3 or something like that, you know. And then that's kind of how you would do it. To have like a signed value, you would split it again, so you would have like 1, 3, 4. So 1 bit would be the sign value, the next 3 bits would be the whole number, and then the next 4 bits would be the decimal or the fractional parts. And then you kind of have to you would have to use like a mask value. So you would kind of have to sort of AND the number with these bits here to get the whole number, and then you would have to shift them by 4, and then to convert them back, the whole number part converting back is fine. The fractional part would be a bit tricky, but anyway, that's kind of how fixed point works on the DS format. It uses, so that there's three fixed point number bits that the display list format uses for the various parts of the mesh data. So the one that we will be using is this one here, as it's the lowest one here, which is 1.3.12. As the this was the texture coordinate format. So we have a range here of like 7, but it can take positive and negative numbers here. So as you see here, the format we'll be converting floats to is the 1.3.12 format. So numbers up to 7 or smaller than -7 in range there. Fixed point is a bit complicated, But if you are using a system that doesn't support floating points, then you kind of have no choice there. So anyway, let's get into the actual stuff now. So first off, I'll show you some of the models we'll be working with. So we will start off with some low poly models. So I have a barn model here, which I've created, and then I have, where is it? Not sure why that one's okay, for some reason this one doesn't seem to be rendering. I don't know if it's let's try and, oh, it might be because I moved it. There we go. So we have like an apartment building there using a simple texture. So these are simply constructed here. This is just a cube, and then on the top here I inset the top and then scaled it up slightly. And then one thing I should have done is I should have deleted the bottom face, as this would not be seen, so it would be wasting precious resources having the bottom on it. So these are two props, if you like, in the scene. So let's jump into the scene now, actually, so you can see what's going on here. So we've got a faux scene here. We have some stars. We have some custom gumbas which are created. I'll go into where you can find some models to look at in a moment. So all of these models I created myself here. I've created some models to act as sprites here. So this is actually a dome, which I'll go over in a moment. There's two dome shapes here. So we have some Christmas trees here, which are just planes. Again, these are like sprites, if you like. And then we have a custom cow here in our barn moving around. So this is a conversion from a Wii model that I found, so that it was reduced and remodeled so that we could use it on the N64 here. And then we have some girls here who are also using custom dome sprites. So these are flat images textured onto domes to kind of give some slight depth to them. And then the whole scene is kind of constructed how I sort of construct levels, so I'll go into that in a moment as well. There's a few different textures for the Gumba models here, and one thing I added is rotating and pivoting them around, so it appears that there's some life to them. So they've each got their own sort of speed of rotation. And then in the barn here, I cut out some holes for windows and a path going through. I'll show you to do that in a moment as well. I have tested this on my own N64 and this works fine. We get less frames per second on the real thing and it kind of looks a bit more tidier, although there is obviously some graphical glitching on the real thing as well. It's just the nature of things. So as you can see there, that's a pretty complicated scene there. There is a load of models in here. So if I go into the graphics define here, these are all the various textures here, and we have a number of different mesh here. So as you can see, these are all the mesh using the F16 format here. As I said, 132. So if we look in the various data files here, you have the signed 16 one here for the various texture coordinates, positions and normals, and then these are the indices arrays here, which basically says which group to draw. So some of these, as you can see here, some of these are reused multiple times. And if I go into this here, you'll see this basically takes in the same as the stuff in the previous video, except the format's slightly different here. So if I go into this here a moment, so I've still added in the floor plane here because it's easy to manipulate in here. And then you'll see we add the floor mesh from the array here, like we did in the previous video, except this time we set the, you can set the UV scale not via a constant here. So as this is not a const array, we can obviously manipulate this. So you could add a few other floor planes here. It's just kept separate like this, so you can change the texture coordinates. So this was the way to generate a display list in the previous video, and then this is the updated way to do it. So all what happens here is these are the floats which hold the normals, the vertex positions and the texture coordinates, just like in here. So we still need all of these parts here, but how we get them is we reconvert these numbers back into them. So these are in groups of we have these three here are actually vertex positions, the next two are texture coordinates, and then the next three are normals. So it's actually grouped like this here. These numbers here will be converted into floats inside here and then put into these here. So we use this here And then, like I said before, to convert those values to float, we basically shift, or we divide that value by 1 shifted right 12. So I think that's, let's have a look what 12 is there. I think it's like 1024. Just open up the calculator here. Okay, this isn't working as expected here. That's not fucking right now. Oh, in fact, that's probably better do it here actually. There we go. Finally got there in the end here. So 4096 is basically to convert back, we divide the variable by 4096 here, and then to convert a float to an F16, which is basically a short, we multiply that by 4096. So all we do here is we basically iterate over the vertex array here, taking each of these. So you see that we take 8 at a time here, and then that then allows us to use the new vertex thing here, which basically converts all of these into a position text coordinate in a normal. And then once we've created an array with all of these parts in, we then copy the indices, and then just like above, we then end up with an array of vertex and an array of indices. And then we record our display list here by using the draw elements with GL triangles. We get the indices count from iterating over each of the vertex there. As every time we go over 8 here, we have like 1 indice, and that's how this basically converts them into usable meshes for us here. So let's jump back into Blender a moment here, and then I'll show you how these were kind of made here. So if we hide these a minute, let's set the 3D cursor back to the world origin. So that thing there is our 3D cursor, and then if we add a cube. Now what we want to do is we want this to first we'll change the size back to 111. We'll then correct the scale to 0, zero it back in, so now these are all 1. Then we'll move that up. So weirdly inside here, Z axis actually is up and down and Y is actually forward and back. That's one thing to bear in mind here. So you'll see now, if I go into front view here, and if you zoom in, you'll see the various square parts here. Basically, they're sort of like 10 each. And you'll see the origin is this dot in the center there. So we want the origin at the bottom here. So if you right click that and then set origin and then origin to 3D cursor, so you'll now see that the origin of the cube is now at the bottom there. Now if we rotate that around by pressing the middle, if you have a middle mouse button here, you'll see that the origin is now at the very center there. So if we select our cube here and you press R to rotate, now we would only want to really rotate this on the Y axis in the N64 itself, as this will be like a static model, if you like. So we will go into the material properties here and then click on this base color one here, this little button here, and then select image texture, and then you would then load in an image you would wish to use. For me, I will just use one of these existing ones here. So this is got like a window texture on it here. So we'll go to the front view. First we'll triangulate these faces. Then we'll go into the UV editor here. So this is the texture we're working with here. So if you press the period button or delete on the numpad, it automatically zooms in a face for you. Make sure you are on face and edit mode in here. Select both of these and then project from view bounds. This is then scaled that up, although it's not right. So let's try that again. There we go, now that looks right. However, what we want to do to get it to look right is, if you select all these in here, and you press S to scale, press 4, and then with this being scaled out here, you end up with like texture wrapping here. And then if you press G to move this, you can move it around so that you get things looking kind of right here. I think that looks kind of correct there. And then again you would do the same for the other faces here. So if you press 3, zoom it out. So if you hold down Shift, press the middle mouse button and then move around your mouse at the same time, you can kind of drag the model around. So select both the faces there and then project from bounds there, scale that by 4 there. So you could quite easily do this instead using the press A to select them all. Okay, I'm not sure why that's not sort of doing that there. So then go back into modeling here. So I'll show you how I created the doorway entry there. So make sure you've got this one selected here and click off that, and then we want to create a new model. So Shift and A, create another cube, and then scale this one down. So what we're going to do, go into 3, so we're viewing it from the side here, and then you can either, in fact no, that's not going to work. Press 3, click on the other cube, press G to move it, and then Y so that it's moving on the Y axis. Move it along there. So this one here is going to be used to cut a shape going through there. So select this, press S to scale, and then press Y to scale on the Y axis and scale it out like this, and then rotate round to the front view, and then scale this on the X axis. So S to scale, and then press X, limit to the X axis only. And then we will scale this on the Z axis now. And then we want to move this up, so go into the front view. And then you can click on snap here, and then what this will do is this will limit the movements to steps in these squares here. So if you press G and then Z, you'll see it moves aligned to these squares here. Now if we rotate around here, we now need to get this to go fully through the other cube. So press this one and then G and Y to move it through. There we go. So now that's straight through there. So what we can do now is select the building cube, and then on this list here, click on the modifier properties icon, and then from the add modifier, select Boolean. Make sure you're on difference, and then use the eyedropper tool here, and then select the other cube here. Now what this should have done is, I think it has, you should be able to see that it's cut out the middle section here. So now if we click on apply here, and then click on this other cube here, move it out the way, you'll see we've now cut a path through the center there. So this could be like another building model we were going to use or something. Of course you would probably want to tidy that up with possibly another sort of texture in there. And then another thing I would recommend doing when we work with these is any face that you're not going to see, you can just kind of get rid of. Another thing to note here is these faces in here are not triangulated. So select all of these and then triangulate them first before you start doing anything to them. What you may notice as well is some of these triangles, if we zoom in, might not have put things together right. Sometimes you can change some of these parts here. Yeah, so you can kind of see it here. So we'll remove some of these here. So if you press G and then G again, and then move that vertex so it aligns with that vertex, this will allow, do the same here again, fact, this face here isn't quite right. So we'll need to triangulate that face again. So select everything and then face and then triangulate faces. When you cut things, you might end up with some irregular vertex afterwards. Some of this you'll only learn from modeling, as in some of these shapes we can get rid of. It's easier to see things if you go on to flat shading. So some of these triangles could be amalgamated together. So we'll take that one there and then move it up. In fact, let's turn off snapping first. So if you press G twice, that will allow you to move that up. So by doing this, it allows us to reduce the polygon count. Obviously that only works in some places. And then we'll have a look around, make sure everything looks right. So what we'll do now is we will give this a roof. So if we go into top view here, and then we go into inset faces, make sure we select these and then press I to inset faces, and then scroll in here. You see we've cut like another sub face inside. Now what we can do is move that one up. So if we press G and Z, so we now have a roof and a through tunnel, if you like, and then we'll have to re-triangulate the faces again. So A to select all and then triangulate faces, and then this would be that model complete there. So if you press tab or go into object mode here, and then when you're building these things, you want to hide everything you are not working with here, so you get an understanding of how complex the model is you're creating. So you see here we have the statistics of this model, so we know it takes 48 triangles. So to display that, you click on this one here and then you select statistics, and then you know how many triangles a model has before you export it. Obviously this is important because everything on the N64 is pretty much low polygon, which means low triangle. Some other issues you might have is if you extrude things. So if we move things in the wrong way, you might need to know the face orientation. So if a face faces the correct way, it will be blue. So I'll give you an example here. So we'll select this one here, and then we will flip the normals. So sometimes you end up with a model with a flipped normal. If you have a flipped normal, then this is what you can potentially end up with. Although in here, one of these settings here, I believe, has backface culling. So if we deselect that, the red color there means that that normal is not reflecting correctly at the camera. So if you were to import this model onto the N64, that face there would actually be hidden because it was facing the wrong way. So what you would do to correct that is normals and then recalculate from outside. and now that's sorted now. So now if we go into the texture view there, and then we unclick the face orientation, that's now fine. And then once you've got your model how you want it, what I would do then is get rid of faces that you know the player will never see. So if you press X and then just delete the faces there, and then the same there, and then from the front you will see everything kind of looks fine. However, if you were to look underneath it, there's obviously these missing faces here. But note that the triangle count has dropped, which is what we are kind of going for with everything here. And then once you've finished with everything here, before you export it, make sure there's no location value on here or rotations, and that the scales are at 1:1:1. This would then be fine to export. I won't export this now, as there isn't any real sort of need to put this in our project. So what I'll do now is I will show you a site to find models to work with. One thing that I had to sort of do was to try and figure out how much detail the N64 normally places on its models, as in how many triangles or polygons does a normal sort of a model actually have. So if you go to the modeler's resource, right, I'm not sure, but this is giving me a load of garbage here. So in fact, go to Spriter's resource. That's the easiest one to go to. So go to there, and then go down here. You'll see the models resource here. Go into there, and then it will have some models which have been uploaded here. So we're interested in the Nintendo 64. Although some other systems you can use is the DS. And we will be working with one of these models shortly, if I can remember where I actually got it from. I think it was in one of these here. No, it's definitely not that one. Anyway, so I think it was one of these characters here I found, and I downloaded. Here we go. Yeah, this is one here. So if you open that, what you'll see what the model actually looks like itself, and then if you download that, then you can get an idea of how these were constructed, as in what sort of what shapes were used, and then that can be a basis for some of your own models. So I've already downloaded that one. I'll show you that one in a moment. So we'll hide that model there, and then I'll load in a model here. So you see I've downloaded a load of these. I've extracted them here. So the Shy Guy model is an OBJ anyway, so that's the most easiest to use, and there he is. And then you'll see that the origin is at the very center bottom there, and then if you look underneath, you'll see that the bottom of that one has been cut away as well, because obviously when you're working on the DS or the N64, every polygon counts, so you want to limit them. And then another thing to note there is he only uses 32 triangles. And then if we go into, we select him there, go into edit mode. and then you'll see that there's all different parts of him actually selected. What we'd recommend is when you import these, select everything and then go down to merge vertices by distance, and you'll see there 21 vertices have been removed, and that's because sometimes these uploaded models seem to have loads of other stuff, bits and pieces with them. I'm not sure how they are actually ripped from the consoles, but just make sure you do that. So what that does is sometimes you'll have multiple vertex aligned with each other, but they appear to occupy the same space. So what that can do is that can create hidden faces or other graphical glitches. So by using the merge by distance and then by distance, what that does is any vertex which are close together, they'll be merged into one, and that will then reduce the amount of vertices and potential geometry in the actual model itself. So another thing I'll show you here as well is if we go into UV editing here. So this is the PNG file from there, the texture coordinate, sorry, the texture for that. So if I go to downloads here, and then we have a look in the Shy Guy folder, you see we have a texture map there. So that's a 32 by 32 pixel image, so that means the N64 would be happy to load that as it is. And then you'll see that this is basically just one half of them. So the shape kind of looks symmetrical here. So one thing we can do, so if you select some of these faces, okay, that's weird. Almost they almost don't appear to be actually on the texture themselves. That's very odd. So we'll fix some of this. So what we'll do first is we'll create an alternative one of these, and then we will import it into our scene. So we'll open that with LibreSprite there first. So what we could do is and so what we'll do now is we will change the colors in that. So we'll go into the GIMP graphics program there, paste that as new image, zoom in on there. We will then change the colors there. And then we will copy that one back. And then we will save that. And then what we'll do is we'll fix this model here. I haven't imported this into the N64 yet. Thankfully, I've just noticed that the texture doesn't appear to align with that. So one of the other things we'll do, so if you press Shift and Z here, we now have a wireform of our model here. So go back to 1, if you press 1 for the front view, and then we'll select half of that and get rid of it, as we won't need it. And I'll explain this in a moment here. So we'll create our new texture. We'll now load in our new image. So here we go. So that's kind of looking fine there. So if we go into UV editing there, for some reason that's not in there. So let's drag that up so it is actually inside. And then we'll put that to constrain to image, and then it's at corners there, so we'll make sure that it's inside. There we go, so he's correctly inside. In fact, I want it snapped to center, not corner. So if we look around now, everything kind of looks fine for him. So the reason why we work with half like that is it allows you to just create like a texture for half of the image, and then we can go into object mode and then add modifier, and then we select mirror modifier, make sure the axis is X, click on flip, and then enable clipping. And you'll see here, as we have the texturing correct in one axis, it then mirrors everything and fills in the other half for us. So this looks fine here. We'll apply that. Another thing to note is this has a rotation on it, so we need to get rid of that. So that's sorted there now. So he also appears pretty small as well. So we'll scale him here, so one of these axes is 1, or sorry, one of the dimensions is 1. We'll then fix the scale. There we go, so his height will be 1. We'll then fix the scale, so that's now 111. So our character looks fine. He's only taken 32 triangles, so he's very low poly there. Let's just go into edit mode first and make sure everything looks fine. Click on to vertex. So let's make sure that there are no overlapping vertex. So right click that, merge vertices by distance. So there's none removed, so we know everything's fine with our model here. So let's export this one here, selection only, and then we want triangulate, keep vertex order. And then there's our model name. So we've exported that. We'll save our blend file. So definitely check out a load of these. The cow model which I was working with was from the Wii here, and then I think that was also from Mario Kart as well. So if you do try and work with some of these high polygon models, you will run into various other formats. I'll quickly touch on one of those in a moment. So now we're going to be adding another model in here. So what we'll do is we'll add another mesh here, and then we will create another array for them. So notice here that I put V at the end and I at the end, and that's just a nice way to differentiate between the vertices and the indices arrays. And then I'll just smash this at the bottom here. So we have our two arrays waiting. So what we need now is to navigate to the OBJ tool, and then if you go into the binary file, you should have the OBJ converter here. So the Windows version will obviously be an exe file here, which is 32-bit. So double click on there and it just opens a basic window, and then navigate to where you saved the model that you exported from Blender. And then here you go, just select the OBJ and then just drag and drop it onto there. It will then navigate to where you want to save it. And then if everything's fine, it will give you a text file there. And then that will turn green. That's you done there now. Now if you navigate in here, open up the text file there, and here's our parts. Nicely formatted for us here. These are the textured vertexes here, and these are the indices which point to the order these should be constructed in. So now what we need is to copy these in. Don't need text file anymore. Now in the main function here we have a load mesh function block here. So all we're doing is add mesh S16, select the vertex and then the indices. So now what we need is we need to place our character in the scene. So there's some easy ways we could do this. One of the things that I've put in the level manager here is there's some miscellaneous objects. I'll quickly talk about some of these in a moment. we'll add a tile for the shy guy. Now the scene relies on a level map, which is this one here. So if I zoom in here, so each model has its own pixel color here. So the top line, you can think of it as like a key which will be used to represent the model in our scene here. So the last one, the last key here was the player, which was white. So we will put our shy guy as a bright green. So there we go, there's our key for our shy guy. So we will we'll place one there, one at each corner. There we go, there's our updated scene. So the purple blocks basically in here, these are just fillers to signify where the building parts occupy. The red colours there, these are the gumbas. As they're so big, they have they take up 4 squares in the level. So this is just a quick way to map out where you're going to place everything. And then once you've done that, then obviously you then need to turn that image into an array. So I use the DS to tile for that, and it's just because it has the 256 bitmap format, which is very useful. So the map's 16 by 16 pixels in size. So we select our map, drop it on there, and then we save that. And then here's our level here. So we're only interested in the bytes parts. So we can close that now. So here's our level map basically. So we've added our tile for the shy guy. So we have some model types in here in our scene. We have the gumba, which actually is also a cow. And the shy guy will also be a cow going forward from here. So we need to increase the amount of those. So I think we added 4 more in. So we'll now have 10 in there. So oh yeah, we also need to add the texture in as well. So let's go to, in fact, did I drop it in? No. So this is the folder where I have the images. So we now need our programs asset folder, which is on the left here. So if I come up from here, this is our project, this is our assets file. We now need to add our texture map. for our Shy Guy character, so we'll copy that one, paste it in the folder there. And then we'll move these side by side, and then we'll make an entry in here for our Shy Guy sprite. So this is 32 by 32 image here. If it was a different size, maybe a different format, in the make file you would add it in. The default in here is RGBA 16, so the Shy Guy texture will be converted to that. I don't know how many colors are actually in there. So let's see if this builds. Let's try and run that a moment. Okay, so that builds fine. So the texture is fine. So we've added our texture. We've added our texture name in here. That will automatically be loaded by our load textures function here. We've added our mesh here for the Shy Guy model. So now what we need is in our level manager, let's come down to the main part of this here. So we have in the level manager, just side by side stuff. So we have some data types here for each model type. The miscellaneous sprite, that can be either a flat plane sprite or the various dome sprites. I think I kind of need to cover those. So are they in here? No, they're not. I'll come back to that in a moment. And then the static one here, these are the barn and the flats. So the only ones really used in here are the initialize, update and draw scene functions. And then in the level manager itself, the initialize block here, it just iterates over the level data array and then compares each of the tile IDs to one of the models here. So what we need to add in here is we need another case and break block. For our Shy Guy there. And then we'll be using the Gumber function to create our Shy Guy, and this creation function just takes a tile X and Y and a type ID to reference the model types. So I could do another enum here. This is just for yourself really to make things look a bit tidier. So the first couple of types are the Gumbers. The next one is a cow, and then the next one is our Shy Guy. So that one should be 5. Yep, so this is a kind of how I create some of the simple scenes in my own sort of games here. In the level initialize, I would kind of have like a case select block like this, and then each sort of different type call like a manager function to create a new instance of them. So the manager type here for the Gumba. So all we're doing here is the Gumba data type itself. It has a position, a collision rectangle, although these are not used, but I'll include them there anyway. This is something you would obviously have for your own game. And then the actual model itself has like a roll left and right boolean, and then your value and the roll value, which gives the little animation technique, and then a base texture ID. So the what we need to include here is we'll leave the size the same as the cow. We'll just change the texture to have I not added that? No, I have not. So make sure you include the textures you're going to work with here. So this is basically adding the Shy Guy to our list of Gumba types. See here each type has basically an array list, and then also like a count value to be aware how many are in there. The player start tile is where the camera is placed at the start. So the next one to look at is the update Gumbas. So we don't need to worry here. This is where the moving them, the shifting around of them, there's a min and there's like a limit to the roll angle, so they can only roll like 15 positive and negative. That's what this is doing here. The draw one is what we're interested in here. So we will catch which mesh to use by comparing which texture the model has. As this is being used as like a general purpose kind of like actor, it would probably be better in your own program to give it a different name and also include the mesh in here as well. Initially this was just going to be all Gumbas, but I decided that it would look better if there was more variety in here. And I also wanted to show you how you can create and work with models yourself here. So what we're doing here is we are converting the various bits of data here into a model. So this is basically just being used as like a template, and then we just pass those to the s3d draw model command. So that should be as good to go now. So now what we need to do is try and find them. So I think I put them in each corner. There we go. There's one moving around. I think it's slowly going to turn around. Happy days. So there's one. I think I put them in each corner. There's the other one. So they basically get like a random rotation speed at the start, which is why that one's moving a bit quicker there. So when you kind of design these levels, you kind of will have to play around with a sort of like a world size, if you like, what everything should be. So that works fine there. I'll now talk about the sprites here using these shapes. So first off, code-wise, there isn't really anything else I kind of want to discuss with the code. The core point of the video was to show you how to load models in. This is obviously built on the last video here. There shouldn't be anything too magic in this other code. By all means, have a look through it. There is some functions in here for detecting collisions, so by all means have a check of that. I haven't added anything here, so you see the idea with this is you would create a collision rectangle for the player's camera. I added in some other functions in here, so look, data type wise, what did I add new? Okay, so there's a rect f here, which is basically a rectangle using floats, with some other commands here to basically align a rectangle to a point. So what this would do is it would orientate the rectangle over a center point, which would be useful for like models like this. So you see he has a center point here, but if we had like a tile in the level, then obviously think of that square there as our tile, we would want to align it so that he was exactly center in there. And there's a function for that. There's another function which I use here as well, which is does the opposite. This centers a vector free inside of a rectangle float, and there it's regularly used to construct the scene here. If you have a look in some of these construction functions, you'll see we use the tile size here, so there's x and y in the world, which is controlled by these here. This is the width and height of the level in tiles. Each tile is size 8. So the x and y in this loop would be multiplied by the tile size, and that would give you like a corner location of that tile. But obviously lots of the models have their origins, as in their centers of rotation, at the very center of them. So we then need to move those models across to actually be inside that tile. So I will now load in some of the other models here. So this is the Gumba here, which I created. In fact, this isn't the right one I want to be showing you here. So basically, in fact, this is, I've got other models in here. So I downloaded a Gumba from the N64. I think it was from Mario Kart 64 to have a look at. So this is that one there, which looks quite bad in my opinion. So you'll see that the body is just a plane. So I don't know whether what effects they were kind of using, whether they were turning off depth testing when they were drawing these. But if you put a plane into your scene, then obviously it will only draw from one side. And I kind of felt that this would not be very adequate. The key thing to note is that it takes 144 triangles. So I thought, okay, I'm sure I can beat that, which I did. So this one here, which looks better in my opinion, takes 121. And then I kind of put this one together, basing it on the other one. Obviously I use my own texture. So you create each part individually, and then what you do once you want to kind of export them all in a group is you align everything up. So the head, the body and the feet, and then to export it as one thing, you then select one, select another part first, and then join. These are now considered to be one thing. So another foot, body, join again. Now the body and the feet are connected, select the head, join. And now they're all basically one sort of group. But note that the origin is in the middle of the head there, which is obviously not what we want there. So what you would do then is you would set the origin to the 3D cursor, which would then put it at the bottom there in the very center. And the reason why you would want it in the very center is so that you can rotate him around. This is kind of what he's doing in the scene there, except we are just working with the one axis there. So the y-axis is actually the z-axis when we're coding. So that's how you would set up your model for exporting. This is the star model there. Notice that the star has its origin in the very center, and that is because the idea with it is it can rotate in any direction. So you'll see we can rotate him there, there, and because the origin of it is in the very center of the volume, that's why you would put that one in the very center there. Star was fairly straightforward to add. So if you press Shift and A to add a model, and then you go into Mesh, and then you'll see there's a few different shapes here. One of the extra things I added was some extra shapes, I believe. Okay, they're not actually in here. One thing you could do is, let's quickly go over how I created the star. So I created a plane first. And then you can go into edit mode. You see we have our 4 vertex there. Our star obviously needs more, so what I did was I selected those, and then you can subdivide them. Oh, I didn't want to save that, I've just broken it. So you would then subdivide that, and you see there's another point that's just been added in the center there, and then we'll subdivide that, same again the other side. So what that's actually doing is that's adding an extra vertex in, and then you can scale those in, move those down, and then you kind of get the idea there. Subdivide those and subdivide those. So that plane then is this star shape here. So then what you do is you select the faces, go into front view, press E to extrude, and there's your star. Or you could just find one from the modeler's resource and work with that one instead. So let's go over the sprites that I used here. So you'll see that there's one sprite is a dome which has its origin in the very center here. This only uses 84 triangles. I'll reduce this down here, and then what you can actually do here is to give your sprites a bit more depth. Just load in an image and just switch the textures, and then each texture would be like a sprite frame. And you'll see here, because the origin is in the very center, you can rotate this in any sort of direction. So you could do that with your sprite, or do this. So you could pivot them like that. Move them, although you probably wouldn't really want to move them too much side to side, although you could, because there's no back to it. The idea is that you treat it as a sprite and always kind of point it towards the camera. And then the next one is this one here, which is a different view again. So this one is to be treated as like a sprite again, but the difference is the origin is at the very bottom here, and you've kind of got like a semi-dome, if you like. So the although it appears black on here, the girl texture is obviously transparent, but the you can't see that here. So again, this is another option here for using sprites. Although you probably don't notice it too much on the in the demo itself with the girl character. Her size probably needs scaling a bit more, maybe. So these are two included like sprite characters to use, and these were straightforward. So if you go into Shift and A, go into Mesh, and then go into UV Sphere. Recommend that the drop these down to something quite low, probably like 8 and 6. I think that's this is kind of what the if you looked to reconstruct the Shy Guy, was kind of created from, I would say, a dome or a sphere like this. And then once it's done like this, you then go into Shade Smooth, and you see that it obviously looks better there. And then in edit mode, go to the front view, Shift Z to make it invisible, and then you can just delete faces, Shift Z, and there you go, there's your dome. And then you would have to texture map that. Again, that's straightforward. exactly like I showed you before. So on here, that icon there, select new, base color, image texture, and then load in your image you want to use. We'll take one of these just as an example here. So get the front view there, select what faces you want, and then you would then unwrap these to bounds, and then you would sort of scale that to where you want it. So I would take like the face you're interested for the front, and then for the rest of it you could literally just select all of the faces, and then I would just select them all, press S and 0, and now what you've got is just one dot, and then move that somewhere, and then all those faces would then be one single color. That's a quick way of doing that. And then you would just export that as an OBJ as before. So hopefully this will have been useful to you here. I'll include the level map, and obviously I'll link to the OBJ tool. So in the next video I will be looking to make an actual game, building upon everything we've done so far. I've kind of got a few ideas. I'm thinking of maybe like a Shy Guy breakout game, or possibly a Plant Blitz game in 3D like I made on some of the other consoles, or maybe an Invaders game with Shy Guys. So those are your 3 options for games. Let me know which one you would like me to create in the comments, and I will catch you in the next video. Thanks for watching.